Very good morning, students. So far we have completed up to potential difference is nothing but voltage. Today let me explain about electrical conductivity and resistivity. Electrical conductivity and resistivity, and then resistance. Electrical conductivity. Electrical conductivity or specific conductance is the measure of a material ability to conduct an electric current. So, electrical conductivity is nothing but material ability. So, whatever the material we are considering, the material it may be aluminum, copper or else any metal. So, whatever the material we are considering, we are checking the ability, we are measuring the ability to conduct an electric current. It is commonly denoted by the commonly represented by the symbol or else resistivity, commonly denoted or else represented by the Greek letter sigma. What is a, here it is a sigma. So sigma, this is a symbol for the sigma. The SI unit of electrical conductivity is Siemens meter. What is that? Siemens per meter. Siemens per meter. Siemens per meter. Or else S by M. S stands for Siemens, M stands for meter. So this is the unit of electrical conductivity. Next one is resistance. An electrical, so the picture shows the resistance. The picture shows the resistance. An electrical component resists or hinders the flow of electric charges. So look at here, look at the picture here. What is the resistance do? An electrical component resists or hinders the flow of electric charges when it is connected in a circuit. When it is connected in a circuit. So in this picture, the first one have less resistance, second one have more resistance. In a circuit component, the resistance to the flow of charges is similar to how a narrow channel resists the flow of water. Have you understood, students? What is the resistance do? It resists the flow of electric charges when it is connected in a circuit. So first one has less resistance, the second one has more resistance. The higher the resistance in a component, the higher the potential difference needed to move the electric charges through the component. We can express the resistance as a ratio. Resistance of a component is the ratio of the potential difference across it to the current flowing through it. So here we have the resistance formula. Resistance of a component is the ratio. What is the ratio between the voltage to the current, students? That's it. Ratio between the voltage to the current. The SI unit of resistance is ohm. So the ohm is denoted by the symbol. This like we have tried the ohm symbol. The SI unit of resistance is, what is that? Ohm. The SI unit of current already we know ampere. The SI unit of voltage is nothing but volt. Have you understood, students? So what's the formula here? We have resistance is equal to R. Resistance R is equal to V by I. V by I, ratio between voltage to the current. Have you understood? So where we have taken the resistance formula from voltage. Voltage is equal to IR. So we need to find out R only. So we are modifying the formula accordingly. R is equal to V by I. So we can use this triangle format also for getting. If you wanted to find out the current, we can modify this formula. Current is equal to V by R. Current is equal to, what is that? V by R. Current is equal to V by R is equal to V by I, V is equal to IR. So, we can modify the formula. The units of resistance, now what I told you, the SI unit of resistance is what is that? Ohm. The SI unit of resistance is what is that? Ohm. Electric conductivity of metals. So, already I told you about the electrical conductivity is nothing but is the ability of the material to conduct electric current, to conduct an electric current. So, what is the ability of the silver? The ability of the silver is 6.30 into 10 power 7, copper is 5.98 into 10 power 7, and gold is 4.52 into 10 power 7, and iron is 1.04 into 10 power 7, aluminum is 3.5 into 10 power 7. So, these are the value for the conductivity. And the next one is resistivity. What is that? Electrical resistivity. Electrical resistivity, also known as specific electrical resistance. What is it? Specific electrical resistance or volume resistivity is a fundamental property of a material that quantifies how strongly that material opposes the flow of electric current. What is it? Electrical resistivity, students? Electrical resistivity, also known as specific electrical resistance or volume resistivity, is a fundamental property of a material that quantifies how strongly that material opposes the flow of electric current. The SI unit of electrical resistivity is ohm meter. SI unit of electrical resistivity is what is that? Ohm meter. So, what is the electrical resistivity for silver, copper and aluminum? Each we have a different resistivity. So, for example, the resistivity of silver is 1.59 into 10 power minus 8. The resistivity for the copper is 1.68 into 10 power minus 8. The resistivity for the aluminum is 2.82 into 10 power minus 8. 10 power minus 8. The next one is analogy of electric current with water flow. So, students, already I explained you water flow, which mean current flow. That is current flow we can compare with the water flow. So, how with this picture I can explain. So, look at the picture clearly. So much time I told you we can compare the current flow to the water flow. So, for the flowing of water we are creating high pressure and low pressure with the help of the pump. So, here high and low pressure we are creating with the help of the battery. So, here we have a sand. The sand, which means what is that? It resists the flow of water. Am I right, students? Sand inside the pipe which resists the flow of water. So, here in circuit diagram, resistance which is flow of resistance which is used to resist the flow of current. So, whatever I compared here, again I am telling you voltage flow we are comparing with the pump, high and low pressure pump. Okay. Current flow we are comparing with the size of the hose in sense pipe. Resistance is nothing but what is that? Sand which is accommodated in the pipe, water pipe. And electric current is the flow of electrons through a conductor like a copper wire. We can't see electrons, however, we can imagine the flow of electric current in a wire like the flow of water in a pipe. Let us see the analogy of flow of electric current with water flow. Water flowing through pipes is pretty good mechanical system, that is a lot like an electrical circuit. The mechanical system consists of a pump pushing water through a closed pipe. Imagine that electrical current is similar to water flow. So, again I am telling students you have to imagine here, you have to compare these two. The electrical current is similar to the water flow flowing through the pipe. The flowing parts of the two systems are related. The pipe is like the wire. The pipe is like the wire. You have to compare, students. The pipe is like the wire in the electric circuit and the pump is like the battery, which I explained you already. The pressure generated by the pump drives water through the pipe. The pressure is like the voltage generated by the battery. The pressure is like the battery which is generated by the battery. I mean, the pressure is like the voltage. The pressure is like the voltage which is generated by the battery, which drives electrons through the electric circuit. Suppose there are some dust. I told you already. There are some dust or else sand and rust that block up the pipe and slow the flow of water, creating a pressure difference from one end to the other end of the pipe. In similar way, the resistance in the electric circuit resists the flow of electrons and creates a voltage drop from one end to the other. Energy loss is shown in the form of heat across the resistor. So, energy loss due to the heat across the resistor, students. So, I hope you are understood about this. Thank you, students.